Hi everybody, Mr. Vidic here. Today we're going to learn about the Pythagorean Theorem. Okay, and the Pythagoras was this Greek guy, Greek mathematician, philosopher that lived about 2,000 years ago, and here he is right here. Okay, and he discovered this amazing thing about triangles. Okay, and here's the original his original writing. If you can read ancient Greek, you can maybe read it to us. Okay, but here's what he discovered. Okay, he discovered when the triangle has a right angle, so one of the angles is 90 degrees, and squares are made on each of the three sides, then the biggest square has the exact same area as the other two squares put together. Okay, so I'm going to show you exactly what I mean here. Okay, with using a diagram. Okay, so this is the Pythagoras Theorem, and here's my right right angle triangle here. Okay, and it has three sides. So if I make squares on each of the sides, so the area of this one over here, that would be a squared, because a times a is the area of a square, plus the area of the other square, b, will equal the area of the big square that's made with the longest side, c, over here. So here's the rule. If I square the small side and add it to the square of the other small side, it's going to equal the square of the big side. And that's really helpful when it comes to looking at right angle triangles. Note here that C is the longest side, and A and B are the other two sides. It doesn't matter which one is which for A and B, but it's important that the other two small ones add up to the big one. Okay, so let's do an example here. All right, so let's look at the definition first. Okay, so the definition, the longest side is called the hypotenuse. Remember that word, okay? Hypotenuse. It's gonna come over and over every year in math. So get familiar with it. So here's the definition. In a right angle triangle, and again, this only works for right angle triangles, the square of the hypotenuse, so the square of the long side, is equal to the sum of the squares of the other two sides. And that's basically that's basically exactly what this equation represents up here. Okay, so let's do a little test here. Okay, so let's see if this works. Okay, so here's my triangle, here's my right angle. Let me mark it down here. Okay, so here's one of my short sides is 3, so 3 squared is 9. Okay, that's right there, 3 squared, and I'm going to add that to the other square, the shorter side square, which is 4, so 4 squared is 16. And when I add those two together, I'm going to get 9 plus 16, which is 25. And it should equal to the long side, okay, squared, which is just 5 squared. And look at that, 5 squared, 25 equals 25. So this will work every time, okay? And if you actually put these squares together, so there's 9 squares here, 16 squares here, and there's 25 in the big one. All right. Well, this is very useful information because we don't actually need to measure the length of the long side if we know the two shorter sides. And that's really helpful if measuring might be really difficult. So if I know, for example, if I come up to a street intersection like this, okay, and I'm standing on one corner over here, okay, and I want to know the length of the diagonal across the street this way, okay, well, it's going to be really hard for me to measure that because cars are going in all sorts of directions, and I won't be able to do it. However, okay, if I just walk across this way at the crosswalk and count my steps, and then walk across this way, so let's say I took 40 steps this way, okay, and then I went up and I took 30 steps up, I will know how many steps it will take me to walk across the diagonally if I needed to do that. So it would be 30 squared plus 40 squared would equal the diagonal, and we can call it c squared. So you can just solve the equation using your some algebra skills. So let's go ahead and do a couple examples here. Okay, so again, here would be here's how you would make up an equation like I just did up there, and always make sure that the c, your long side, is on the right side by itself here. All right, let's go ahead and do an example here. All right, so here's my triangle. One of these lengths is 5, one of them is 12, and I'm looking for the length of the long side. So here we go. Write my formula down. A squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. And then 169 equals c squared. And then the last step you want to do, okay, you want to get c by itself. You don't want to squared. So you got to take square root of both sides like this. And the square root of 169 is 13. So the length of c is going to be 13. All right, so this is one of those theorems that's been very, very useful all throughout history, and you're gonna see it over and over again in your math careers. So make sure you understand exactly how to work it. A squared plus b squared equals c squared, and we're gonna do a few more examples in class next time. Okay. All right. So thanks for watching, guys, and see you next time.